Hello everyone. Today we will discuss about some of the basic terminologies in coordination chemistry. So as we know, the hemoglobin, which is a transporter of oxygen, mainly contain iron, complex of iron. Similarly, the chlorophyll, which is a photosensitizer in photosynthesis, also contain complex or coordination compound of magnesium. Vitamin B12, which is a cofactor of DNA synthesis, also contain cobalt metal. And if we take the cancer drug cisplatin, which is a complex of platinum metal, is widely used. So with this we can say there are so many complex compounds which have wide application in our day-to-day life. With this, let us take up now what are coordination compounds in which metal is bonded to anionic groups or neutral molecules by coordinate bond. Coordinate bond is a bond wherein the two atoms are mutually involved in the formation of bond. And if we take up the classification of inorganic salt is formed usually by the neutralization of acid or a base, and there are different types of salt. First one we can take up simple salt, second one is molecular addition compound. As we know, simple salts are the salt which contain only one cation or anion. If we take the example of sodium chloride, mainly contains sodium and chloride ion. And here the second type of inorganic salts are molecular addition compounds. These molecular addition compounds are of mainly two types. First one is double salt. These are formed by the evaporation of solution containing two or more simple salt in stoichiometric proportion, and hence these molecular addition compound, when dissolved in water, they give constituent ions, so hence they are called as double salt. If we take the example of potassium, which mainly contain potassium ions, aluminum ions and sulfate ions with the molecule of water. And there are some molecular addition compound which are mainly formed by the reaction of Lewis acid and a base, which do not dissociate into constituent ions in the solution, and such compounds are called as coordination compound. If we take the example of potassium ferrocyanide, when dissolved in water, it gives simple potassium cation and ferrocyanide complex anion. And if we take the cobalt ammonium chloride, and when it dissolved in water, it gives cobalt amine positive complex cation and three simple chloride anions. So with this, now let us take up what are the terms involved in complex or coordination compound. If we see the complex or coordination compound, see we have central metal atom. This central metal atom is attached to the ligands, and they are enclosed in a square bracket which is called as coordination sphere. And there are some the ionizable ions which are outside the coordination sphere, and these are called as counter ions. And the electron acceptor is usually the metal or the metal ion in which one or more neutral molecule or anions are attached. The acceptor metal cation is usually referred as central metal cation or central metal atom, which serves as a Lewis acid. And if we take up the ligand is ion or ion capable of functioning it as an electron donor. Therefore, the neutral molecules or ions which are directly attached to the central metal ion are called as ligand. These ligands serve as Lewis bases. So, in nickel hexamine complex, Na is the central metal anion and ammonia are ligand molecule. These ligands are of various types, and they are classified on the basis of charge, number of donor site and bonding. On the basis of charge, ligands are classified into negative ligand which carry mainly negative charge. Say for example cyanide ion Cn-, Cl-, Br, etc. If the ligands carry positive charge, then they are called as positive ligand. Say for example NO+, etc. If we take up the neutral ligand which do not have any charge, example water, ammonia, carbonyl group, etc. So depending upon the basis of the number of donor sites, they are classified into monodentate or unidentate ligand, which can coordinate to the central metal atom or ion through one donor atom and form only one coordinate bond. Example: water, ammonia, OH minus, Cn minus, O2 minus, etc. If the ligands which coordinate to the central metal atom or ion through two donor atoms and form coordinate bond are called bidentate ligand. Example: oxalato ion, ethylene diamine, etc. If the ligand coordinate to the central metal atom or ion through more than two donor sites, then they are called as polydentate ligand. Example: ethylene diamine tetraacetic acid ETTA, which we call it as, is an example of hexadentate ligand. And on the basis of bonding, they are classified into chelating ligand, in which the polydentate or bidentate ligand form more than two or more coordinate bond with the central metal atom in such a way that there will be formation of 5 or 6 membered ring, and which is called as chelating ligand, and the resulting complex is called metal chelate. This property is called as chelation. So this here is an example of formation of ethylene diamine complex with Cu plus 2. And if the ligands contain more than one coordinating atoms, then they are called as ambidentate ligand. So NO2 can coordinate with the metal atom or ion through either N or O atom. Similarly, thiocyanate can coordinate with metal atom or ion through either sulfur or nitrogen atom. So such ligands are called as ambidentate ligand. And in coordination sphere, the coordination number of metal atom or ion is defined as the number of ligand donor atoms which are directly bonded to the metal is called as coordination number. Say for example, in nickel hexamine complex, the coordination number of nickel is 6. Similarly, we can give some of the examples for coordination number. So in tetrachloroplatinum complex, the platinum has the coordination number 4. So similarly, the oxidation number of central metal atom in the complex is defined as a charge if all the ligands are removed along with the electron pair that has to be shared with the central metal atom. Say for example, in copper tetramine complex, copper tetramine complex, ammonia is a neutral ligand, monodentate ligand. So let us take the oxidation state of metal is X. Therefore, the charge carried on the ammonia is 0. So total charge on the complex is plus 2. Therefore, the oxidation number of copper is plus 2. With this, I think we have completed almost all the basic terminologies which are involved in the coordination compounds. Thank you. And in addition to this, we can take up the coordination polyhedra, which is related to the geometry of the complex, that is the spatial arrangement of the ligand which are directly attached to the central metal atom or ion, defines the geometry of that about the central metal atom, and most of the common geometry are octahedral, square planar and tetrahedral geometries. So if you take cobalt hexamine complex, wherein the cobalt hexamine complex has a octahedral geometry due to the presence of 6 ligand, whereas in nickel tetracarbonyl complex, due to the presence of 4 carbonyl ligand, the structure proposed or the geometry is tetrahedral. So like that, we can give the various polyhedra or geometry for the complexes depending upon the number of ligands. With this, I conclude the basic terminologies in coordination compounds. Thank you.